So, my name's Meredydd. I'm CEO of Anvil. Anvil is a platform for building full-stack web apps with nothing but Python, and that makes it kind of an abstraction over the web. So today I'm talking about abstractions and the perils thereof. And my focus is on the wrong window. Excellent. Try again. Start with the basics. What is an abstraction? So, in programming, generally speaking, an abstraction is a simplified representation that lets you deal with usually a piece of technology, without having to get all bogged down in the details of how exactly it's working. And this is absolutely fundamental to computing. Let me walk you through a few examples to understand what those are. You'll have things there. Common abstractions we encounter in everyday life. Files, if we work on a file system rather than using a disk. TCP, instead of throwing packets into the void. Python, instead of writing machine code. So let's look at files. I have, physically sitting in my computer over there is a disk. And as far as that disk is concerned, its job is to store a whole bunch of bytes. And the computer can ask it to write this, write a byte at, position 3,478, or to read the bytes at that position. And this would be a really awkward way for me to store data if I were using my computer. So my operating system provides this abstraction. Instead of having this raw slab of just a constant huge array of bytes, it gives me a file system. I have a hierarchical set of directories, I can create files, I can rename them, I can edit them, I can append to them, I can use the data storage capability that the hard drive gives me with a much nicer abstraction. And that enables us to write basically any code, any programs that we write. We rely on abstractions like these. What about TCP? So if you use the internet, you may or may not have had to delve into this in great depth. But the internet itself is an amazing abstraction over millions of miles of fiber optic cable and a whole bunch of very expensive routers. But what it presents to you is it's kind of like a postal service. I can toss a postcard with the address of another computer onto my Wi-Fi network. And the internet will bounce it through its various infrastructure in ways known only to itself, and usually, most of the time, not always, but usually, it will pop out at the other end at the computer whose address I've written on it, and it can send me a packet back. And while this is a really great way to run a planetary communications network, it's a real pain to program against. And so, on top of the Internet Protocol, IP, we built TCP, the Transmission Control Protocol, and that is an abstraction that says, you know what, I know there's this unreliable toss a postcard into the ether thing between you and me, but I'm going to pretend that there is an ordinary communications channel like you might expect down a serial port or something. Everything you send is definitely going to arrive. I'll make sure of that. It will arrive in the order you sent it. And these are not naturally properties of the internet, but TCP, exchanges these packets back and forth, works out how long it's taking things to get from A to B, notices if one of them went missing and retransmits it, and holds up the line until everything can be transmitted in the right order. And I don't think it's an exaggeration to say that TCP, the abstraction, is an essential ingredient in basically building any internet service that exists today. Because it's just too much of a headache to deal with the raw internet, so we use the abstraction. Let's get a little bit closer to home. Python's a way of writing programs that run on a computer processor. The processor understands a very, very, very basic set of sort of binary coded instructions. Over here on the left, you can see the set of instructions that's required to describe the kind of most minimal function and then call it in x86 assembly code. Python is an abstraction over running things on computers that allows us to write much nicer code like the stuff on the right, define a function, return something, call that function, do something with the response, and allows us to do it in a way that gives us flexibility, power, and ease of use. So abstractions are, although I've entitled this talk "The Perils of them," abstractions are vital. It's a very early quote in computer science that every problem in computer science can be solved with another layer of abstraction. That one's from Cambridge hometown hero David Wheeler, who invented, oh gosh, functions and recursion and a whole bunch of computer architecture basically in his first year on the job. It was the 1940s, it was all up for grabs. Oh dear, I have just accidentally navigated right to the end of the presentation. Let's not do that. Here's the problem then. Abstractions have downsides. One of the biggest ones is that abstractions leak. They can't perfectly smooth away the wrinkles of how the underlying technology works. Let's look at files. Files are abstracting over the fact that all of your data is somewhere in this big array of bytes, and you know, if you're accessing little bits all over the place, then it's all over this array of bytes. And if you're using a disk with spinning platters, then sometimes it's really important to know that it's going to be faster to read a file from beginning to end all in a row than it is to jump around inside the file, because literally the head of your hard disk is jumping around across the platter to do it. That's an abstraction leak. I have to abandon my illusion that everything is just files and directories, and I have to think about how the underlying technology works in order to use it effectively, which, you know, that increases cognitive load on me, makes me work. I don't like that. TCP. When a packet on the internet drops, the TCP endpoints, their job is to work out that it's dropped and then retransmit. And that, that can take time. And so if you're sending real-time data, like say a video conference over the internet, you would notice that if you're sending that real-time data, there would be random hiccups as TCP recovers from a piece of packet loss. And again, that's a detail of the underlying implementation that's leaking up to your use of it in the abstraction. Python, oh gosh, the abstractions leaking all over the place. Let's go with destructors. So the del method on your objects. Well, when does that get called? Well, if you really want to dig into the answer to that, the real answer is about how Python allows you to do things like just create an object, make me a string with this content without having to worry about allocating and deallocating memory and working out where in, what address in your RAM is going to arrive. The Python interpreter takes care of that. And part of the implementation of that abstraction is cleaning up that data and, marking it so that it can be reused when you're done using it. And that requires reference counting and garbage collection, and the precise operations of that system influence when your del method is going to get called. And to really understand how to use that effectively, you're going to have to understand how the Python interpreter does its thing. Again, the details of the implementation are leaking up to someone who's using the abstraction. It's inevitable. But abstractions can do worse things than leak. Abstractions can fail. You can have a thing that you need to do, that the underlying technology supports, and your abstraction can simply not let you do it. So let's take that TCP example. I want to build video conferencing software, say. I actually don't care about all the bytes of my video frames arriving at the other end reliably and in order. I would much rather lose one and get the next one there on time. It'll be a slight stutter, user won't notice. If there is a 2-second stutter while TCP goes and realizes what was lost and retransmits all that data, that's going to suck much worse. I need low latency, unreliable transmission. Tough. I simply cannot do that within the abstraction of TCP. The abstraction has failed me. Even Python's abstraction fails. Python is run by the Python interpreter interpreting bytecode. And one of the consequences of this is that numerical computation in Python is slow as anything, because every operation has to go through this Rube Goldberg machine of the interpreter. If I want to write high-performance numeric code in Python, I just can't. I just cannot make that interpreter go fast enough. My abstraction has failed me. So while we're talking about failing abstractions, let me get my rant gloves on and talk about the web. Because the web is an absolute mess of abstractions. Let's think about it from the perspective of your data. If you're writing a web application, your data is probably going to start out as rows in a database table accessed by SQL, which is, again, it's an abstraction over data storage. Different abstraction to files, also a useful one. But of course, once you've got it out, you're not going to sort of make real heavy use of that abstraction. No, you're immediately going to turn around and turn it into objects in some server code, probably Python objects in present company. And those have a different abstraction for representing them. They've got methods and attributes. And then, of course, you're going to turn around and serve those over HTTP as JSON on REST endpoints with like a really weird different set of limited verbs, different abstraction altogether. But of course, on the other end of that HTTP is some JavaScript code that's reassembling that data into JavaScript objects with a different set of attributes and a different set of methods. And then that JavaScript is going to have to turn those into DOM objects, which is an abstraction over how the browser deals with things. And then the browser is going to have to turn those into pixels with CSS. And that's a lot of translation. The day-to-day work of web development is largely translating your data between different abstractions. And this work is tedious and repetitive. And it's tedious and repetitive in a way that attracts exactly the wrong kind of magic. What do I mean by the wrong kind of magic? Well, I'm going to explain by taking a totally unfair potshot at SQL Alchemy. So if you are not familiar with it, SQL Alchemy is a really cool library, which is why this is an unfair potshot, that lets you, that helps you bridge that gap between SQL database and Python objects. It lets you write lines of code like this, query book, filter, price, book.price is less than 20. That's nice. Of course, the mechanism by which this sensible-looking Python expression gets turned into SQL I can run against a database is black magic. We're talking meta-classes. We are talking Python operators overloaded to do something completely different to what they normally do. If you think that book.price is less than 20 is an integer comparison, I've got news for you. And if you try to do something expecting it to be that way, you will come a cropper. The abstraction will leak. And you can probably get away with it if you do that once. But of course we don't do that once, we do it at every level of this stack because it's all so tedious and repetitive. So we bring in ORMs like SQL Alchemy to help us turn our database tables into objects. We bring in REST frameworks to help us express those objects as REST endpoints. We bring in JavaScript frameworks like Angular's resources to help us reassemble those objects into JavaScript objects, that JSON into JavaScript objects at the other end. We have templating engines to help us turn those JavaScript objects into DOM. We have CSS frameworks to help us turn those into pixels. And those are all another layer of abstraction, and they are abstractions, all of which leak like hell. And so if you need to understand web development, you need to understand all of the things on the left and all of the things in the middle and how they all interact with each other. It's a mess. And this is why web development is so hard. They say every problem in computer science can be solved by another layer of abstraction. Well, every problem except having too many levels of abstraction. And boy, does the web have those. So with Pythonists, let's stack that up against the Zen of Python. Simple is better than complex. Did that look like a simple system to you? If the implementation is hard to explain, it's a bad idea. Well, who knows how the inside of Angular or React work? Me, barely. For one of them, maybe. There should be one and preferably only one obvious way to do it. Well, this is a famous one. Ouch. That's just at one layer in this stack. And, I joke I'm wailing on the web, and yes, I am wailing on the web. The web is awful. But PEP 20 isn't just about a programming language. PEP 20 is a guide to the design of abstractions. These are rules about abstractions. The abstraction should be simple to use, and if it's hard to explain, it's more likely to leak. And one way to do it is making it easier to understand again. So if the abstractions that make up the way we program the web are really not well designed, what should we do? How can we do better? And Anvil is our attempt to answer this question. So here's the state of the web. There are so many different abstractions here, and we kind of need to create an abstraction over the web. And the problem with that is we're adding another layer of abstraction. This is just going to interact with all the others and get messy. So the thing we did was replace this, or these levels, these frameworks, these extra abstractions with one big one we've chosen. And the big abstraction that we have chosen is the Python programming language. So what we did is we created a visual user interface toolkit that is based around Python. It's got a visual builder. Client-side code for Anvil applications is written in Python as well. We compile it to JavaScript to run it in the web browser, but you don't have to care about that because that abstraction shouldn't leak too much. And of course, that instead of dealing with the DOM, that client-side JavaScript code can interact with the UI toolkit as Python objects. Python on the server, obviously. But once you've got Python on the client and Python on the server, you don't need to mash all your data into JSON HTTP anymore. You can just make a function call. We've even got a database whose abstraction is Python objects. It's not SQL with an ORM, it is a Python object-shaped database. Of course, you can use the standard SQL stuff if you like, it's just Python, but we really have tried to create an abstraction that is consistent all the way from the back end to the UI. Now, I've just talked about all that stuff with the abstract and waved my arms, but you're not really going to get what I mean until I give you a demo. So let's go with a demo. Get rid of that. Give you a web browser. So what I'm about to do is just show you what I mean by building an application in Anvil and show you this abstraction in action. So here I am at Anvil.works. I'm just logged into the editor. I'm going to create a new application. I'm going to show you just like a simple Hello World app. So I'm going to call it Hello World. And here we are in the Anvil editor. This is a web page, and here, this is a toolbox of things I can put onto that web page. So for example, if I want to put a title on my page, I take a label and I drag and drop it up here. And now it's an object, it's got a variable name. I can change its properties. So I can say, well, the text on it should be Hello World. Pretty straightforward. Okay, let's make it interactive. So I want this thing to prompt me for my name and greet me my name. So I put a card on there. I'm going to want a label here to prompt the user to enter their name. I'm going to have a text box here so they can answer that question. I'm going to give this one the name box. Every component in Anvil has a variable name so we can access it from code. I'm going to put a button here for them to click when they're done. Make it a bit more prominent. And you can see what's going to happen here, right? They're going to enter their name, they're going to click the button, and a message is going to appear saying hello to them. So we'll add a label for that message to appear on. I'm going to call it message label. And I can change some of its other properties as well. I can make it centered, I can make it big, and so on. So I've just built my user interface. Obviously, that's a lot faster than it would have been with HTML and CSS. But if I look at the event handlers for this button, when this button gets clicked, this is the Python code that executes. So, and all the things that I've dragged and dropped onto my page, you can see are available as variables in my Python code. So if I want to set the text on the message label, which starts out blank, but I want to set it based on the text in the name box, I can just go self.messagelabel.text equals hello self.namebox.text. All right, let's run that. All right, so we've just built an interactive application and actually deployed it on there. It's not quite deployed on the web. Let's publish it. Okay, now it's on the web. This is like a Google Docs private sharing URL. If I don't send you the URL, you can't access it. But let's go with hi IndyPy. Okay, you could now all open your browsers or your mobile phone and go to hi-indypy.anvil.app, and you'll see this app loads. So we have just built an application and deployed it on the internet with nothing but Python, which I think is pretty cool. Now, of course, this was all very well and good, but all of this Python is actually running in the web browser. And I mean, this is in many ways good, gives you snappier responses, but obviously any serious application is going to need some server-side code as well. So for that, we have server functions. So we have server modules. So this is an ordinary Python module that runs on our servers. Ordinary Python module, ordinary Python function called say hello. Takes a name argument. It prints hello name. But what I can do here is, hang on, let me zoom this in so people can see it a little bit better. What I can do here is I can tag this function anvil.server.callable. And what that means is that this function running on the server can be called from the browser. So now when the button gets clicked, as well as updating the UI, I can also anvil.server.call, I can call that say hello function. The autocompleter knows, because it's a function call in one language, it knows, oh, it wants one argument that wants the name, so I can pass in the text from that name box. And now when I run this and put Calvin's name in, I can see I've got some output in the log file. So that's a print statement running on the server, triggered by this UI we've built with nothing but Python. And now we're really in business, because sure, there's limits to what you can do here. You know, you're not going to be opening a connection to a Postgres instance or opening, TensorFlow model in the web browser. But on the server, this is just a Python interpreter. You can do what you like. You can, import scikit-pg2, connect to your database, go. Import scikit-learn, do some machine learning, why not? Go. Now, in practice, the first thing everybody asks for is a database. How do I set up a database? So we've actually got one built in. This is the Python native database I talked about earlier. It's backed by Postgres, so you can stick terabytes into this thing if you want. I'm going to be a little bit less ambitious. I'm just going to store all the names that get entered in this table. So I'm going to have a text column here for the name. Oh, if I can spell. And then let's go with a date and time column for when that name was entered. Okay, well, that's it. I've built my database. This table is called apptables.visitors, and it's accessible from our Python code in exactly the same way as those components were accessible from our Python code. So let's go to the server, and now, as well as printing that log message, we can also take apptables.visitors, and we can add a row. We can fill out the name column with this name that's just been passed in to us. We can fill out the when column with datetime.now. If we run this, anybody wants to unmute and tell me my mistake? 3, 2, 1. Okay, I'll find it out the hard way. I forgot to import datetime, so this is going to blow up. Name datetime not defined. Oops. Of course, I can click and go straight back to the line of code where that happens. In fact, I can even follow the stack trace and see where that came from in my browser, because it's just a function call. And why shouldn't you be able to do that? No grubbing through log files, it's just a function call. Okay, enough showing off. Let's actually make this work. Okay, so I've entered a couple of names, and if I go back to the data table, we can see that we have added 2 rows to that table. So I have just built and published a database-backed web app with nothing but Python in a very short period of time. I'm going to show you one more thing that is relevant for the rest of this talk, so bear with me. I'm just going to show you sort of the other half of this. I'm going to take some of this data and show it on our interface. So I'm going to want to display the table of previous visitors. So let's go headline here, whose text is going to be visitors. And underneath it, I'm going to have another card. And then on that, I am going to put a data grid. And the data grid is going to have a column for name. It's going to pull up the name key out of the dictionary-like objects inside it. When entered is going to pull out the when keys. And we can adjust some of these as well. All right, so we've just added a data grid, and inside this is a repeating panel. And the repeating panel has a special property called items, which is any iterable thing in Python. And it will repeat this template class once for every element in items. So let's go to our code in form 1. So this is the constructor for this web page, and when it opens, we want to set the items of this repeating panel to, we need to get the data. Okay, well, let's add a server function that gets the data. Want to make a new Anvil server callable function, get visitors. It's going to return apptables.visitors.search. So that, of course, is a rich Python object. It's a lazy iterator, but we can just return it from the server to the client and use the return value of that function. It's an iterable object, so we can just stick it into the repeating panel items, and we are displaying the list of people. James is spoiling my punchlines in chat. Boo him. So we've got some data entry, we've got some data display. Now, this is very nice, and that was nice and fast and used nothing but Python. But these dates are kind of ugly, right? That's just like the stir of a date time. It's not very pretty. What we really want is to format these nicely. Now, of course, by default, because it will just take the dictionary key-like get item lookups of these keys from the data grid, and that's usually fine. But we can go in and customize what this template is. So we can say, actually, instead of this, in this column, instead of just a generic rendering of the when key, I can stick a label in here, and then I'll add a data binding to say that the text of this label should be set to self.items when, which is, of course, a datetime object, so I can call stir-of-time on it. All right, so now if we run this instead, we can see we've got nicely formatted dates. So to recap, I have from scratch built a database-backed web application with nothing but Python and published it on the internet at hi-indypy.anvil.app in enough time that I could comfortably fit it as a minor demo into my talk. But also what I've just shown you is the way that we've tried to unify the abstraction, or present the whole web as a unified abstraction of you can just write Python code and manipulate Python objects, and you can do everything that way. So, webcam. That was a neat abstraction, right? I've just set this abstraction up, of which I'm very proud, and I'm going to spend the rest of this talk tearing it down. Because remember, every abstraction fails. And if you're building abstraction, you don't get a choice about whether it's going to fail. You get a choice about how gracefully it fails. Let me walk you through some examples, because a bunch of different things can happen when your abstraction can fail, and when your abstraction fails. Let's say it's the 1990s and you've just written a desktop Windows application. In fact, you wrote it a few years ago and you're making nice money off it. and someone comes into your office and says, hey, so there's this internet thing, and we need this application to be accessible on the web. Well, that's going to be a problem if your application is a Windows app. It just can't do that. You are going down with the ship. Your abstraction has failed you and there is no way out. Being accessible on the web is just not a thing you can do with a desktop Windows app. My condolences. And a whole bunch of products died this way. At the end of the 90s, the rise of the web, because they just couldn't make the leap because they were trapped in their abstraction. This is not what you want your abstraction to do to people. It's not very nice. But there are some that will react better. If you've done modern web development, you may have encountered something called Create React App. So Create React App, despite its somewhat ungainly name, is actually, it's an abstraction over the front-end build process. So it is a utility that will create for you a skeleton of an application that uses React and a few other popular front-end libraries. And it will manage like the webpack and the minification and the builds and the dependencies and the transpilation and all that stuff for you. Good, useful abstraction. Of course, the web ecosystem is nothing if not complicated, and sooner or later there's a decent chance that you are going to need some kind of library or some kind of mechanism or some kind of advanced feature that Create React App doesn't support. And the Create React App devs have thought of this. There is a button you can push. You call Create React App -- eject. And Create React App will promptly spit out a Webpack configuration file, all the build scripts you need, and then you are done with Webpack and it is done with you. You cannot use it anymore. Its utility as an abstraction is gone. But on the upside, you can go in and edit your Webpack config file and do the advanced thing that you were wanting to do. So congratulations, you're not going down with the ship. This is an improvement. The downside is, wait a second. I wanted one advanced feature, and now here I am in the middle of the Mojave Desert with nothing but my parachute and a ration pack. That was not cool. So it's still kind of a rude thing for your abstraction to do to people. But there is a better way, and as an example of the better way, I am going to nominate Python once again. We talked earlier about the limitation of the abstraction that Python provides, which is that because of the cost of providing this nice object-based way to program a computer, doing numerical calculations in Python is slow. And if you need to do high-performance numerical calculations, well, your abstraction has failed you. You need not to be there. And mercifully, Python does not eject you. It doesn't translate your Python source code to C and make you maintain it in C forevermore. That would suck. What Python has instead is an escape hatch. What Python allows you to do is to say, okay, I need native performance that's not available in Python. So what I can do is I can write all my high performance numerical computation in C or Rust or any of these low-level languages that can compile, or assembly even, make my CPU scream. And then I can wrap up that computation in a Python function and make it accessible to my Python code. This was not a violent exit. I clambered out of the escape hatch, did what I needed to do in the world outside my abstraction, and then I climbed back in with my dignity intact. You know, you can let's name this library, NumPy. The people who use NumPy, well, as far as they're concerned, they're writing Python because they are. The escape hatch has successfully saved them from having to leave or lose the benefit of that important abstraction. So, needless to say, we want these. This is how we want it to go. And so the question for us, as we are embarking on the monumental task of building an abstraction over the entire web, is how do we build the escape hatches? And where do we build the escape hatches? So I'm just going to walk you through a few examples. So, what about JavaScript? What if I want in my application to do something that I can't do? I want to use some browser feature that's only available from JavaScript. Well, or likewise HTML. Well, here's how you do it. I take my form. This is my Python web page. I can go edit the HTML. All right, there we go. Here is a red box. That took a lot of work. Right, and that's now on my page. And if I drag and drop a button into this, well, the button ends up at the end. That makes sense. Anvil has no idea where in this HTML structure to drop what. That's okay. We can say, actually, there's a slot here called red box. And then we can take this button, edit its properties, and say, actually, it lives in the red box slot. Oh, did I misspell something? Oh, yes, sorry, Anvil slot. I did misspell. There we go. And now the button is inside the slot. This is great. Now, let's imagine that I need to do something in JavaScript. I'm going to imagine that Anvil, for a moment, that Anvil does not have a very well-developed dialogue system that's much more pleasant to use than this. I'm going to say, I actually want to call this JavaScript function, and I want this JavaScript function to alert hello. And now when this, so this is some JavaScript and I want to interoperate with it. Well, when this button gets clicked, I run this Python code, and then I can call self.call.js, say hello, and then pass in my name. Let's set this to the startup form and run this. And now I've got my Python code calling into JavaScript to do something only JavaScript can do. That's kind of neat. And now, of course, what I want to do is climb back into the escape hatch. So I'm going to set this up as a custom component that I can use from anywhere else. And I'm going to make it configurable. So I'm going to say it's got a property called greetName, whose default value is Meredydd. And instead of hard coding my name, I'm going to pass whatever this property was into the JavaScript. And now let's go back to this is the startup form. And you can see that, oh, form 2, let's give this a better name. We can see that the greeter component we've just created is now available in my toolbox. And I can drag and drop it onto my page just like anything else. And I can edit its properties. And all of a sudden, oh, there we go. All of a sudden, I've taken this JavaScript, I've climbed out of my escape hatch, I have written some JavaScript I could not have written from within Anvil, and we can pick any kind of JavaScript library integration you like, and then I have climbed back into the escape hatch, wrapped it up into a component I can use on my form. And you can then have this app as a library, use it as a dependency, and use components defined in it from elsewhere. It's now a reusable component. So that's an example of how you might deal with, that's an example of how we do an escape hatch. What about text editors? I want to use a, this text editor is all very nice. It's got an autocompleter, which I will tell you all about how I built some other time. But I want to go edit it in Vim. Fine. Every Anvil app is a Git repository. Check it out. Why not? Don't know why I put 2 spaces in there, but I have. There we go. Yeah, I'm afraid, dirty secret, I never learnt the Vim key binding, so I'm going to use nano and piss off everybody.
You said Vim. I want my money back.
Yeah, I'm sorry. You can have all the money you're paying me for this talk back, Calvin.
If you really want to piss off people, you want to alias Vim to Nano.
Oh, I'm going to do that to the next person who leaves their terminal unlocked. Oh, back when I'm in the same office as anyone. Oh, gosh. Anyway, my point is that you can then pick this up. You can then take this, use your text editor of choice. I mean, much more likely to be PyCharm. Commit it. Let's say, let's change this. Oh. Push it back into Anvil. And now you can see that this code change has taken effect. And if I run it, the change has taken effect. So again, there is this abstraction of this web-based IDE where you don't have to think about anything outside of it. You don't need to install any local tools. But if the thing you really want to use is PyCharm, or you really want to to mess with the version control in Git, you can. Escape hatch. What about running code on my own computer? So this is, the fancy word for it these days is serverless. Anvil is taking care of ensuring that this code runs somewhere, sometime, anytime I do anvil.server.call. But maybe I want to run something on my own computer. I have a local database on my computer I want to access. I have local hardware. I want to do machine learning on a local GPU. There's lots of good reasons to want to do this. And so Anvil has an escape hatch called the uplink. The uplink is a library you can pip install anywhere in the world. And if I enable it for my app, I get a key that allows me to connect my code anywhere in the world to this Anvil app. Observe. So here is a Python interpreter. I'm going to run this code in that interpreter. All right, so this code in my terminal is now connected to my Anvil app. I can make a callable function. And now if I go and change what happens when this form gets clicked, instead of calling say hello, I'm going to call say hi, which is the function I just defined on my console. Now when I run this, that output appeared on my console. So the call from the web now caused a function to run locally on my computer, and so that could have used, local resources. It could have accessed a local database and got some data. In fact, let's do a version that gets some data, because this is a pretty common example. Right, and now I want to fetch that data from my local data store, and I want to plot it on a chart. So I'm going to add a plot component. Of course, we support the Plotly API. So I'm just going to, as well as getting that, I'm going to say the data in the plot1 object is going to be a Plotly scatter plot. I think scatter's the right. Let's go with a bar chart. Why not? Bar with the y values equal to the return value of anvil.server.call get data. And now when I run this, it's going to go from the browser to the Python script running in my console, get some data out of my local data store, and plot something on the web. So again, escape hatch. We've still got all the advantages of working with the Anvil system, but we're not confined by the serverlessness. We can use it or we can escape from it. I'm going to save a version of that, and then I'm going to kill this plot because of what I'm about to do next. change it back to just using its own code. So that's how we can use resources on our own computer. But what about if I want to run things entirely on my own computer? I mean, let's say I want to run this on, I want to use this as an interface for an IoT device, which, I can't run that always through the cloud, might not always have a connection, wants to work on the local network. Maybe the thing I want to escape from is the fact that I'll be using a development service built by a startup. If a meteorite hits Cambridge, you might be out of luck. Of course, I mean, that's only true if the source code for the runtime isn't on GitHub already, but of course it is. So what I'm going to do is I am going to use the Anvil app server, which is the code that turns the support code that turns all of this code and all of these designs into an application you can actually run is open source. And so what this means is that if I go over here and I go back into my Hello World app, I pull down the latest changes, I can just pip install the Anvil app server and then just run it in this directory. This is, again, it's all bundled up. It's launching its own embedded database, and it's about to pop up a web server serving my app. All right, there we go. My app URL is localhost 3030. Oh, and we've experienced an error. No server. Oh, I didn't save it. I've got some Duff data. Let's go edit that locally in my favorite local text editor. So client code form 1 IndyPy. Oh, that's calling get data. Yeah, we need to comment that line of code out, don't we? Okay, let's go refresh this. Much better. So we've just taken our application and decided that actually the thing we want to escape from is the hosting platform, pulled it out into the open source Anvil runtime and launched it entirely from my computer. And this isn't because hosted services are a bad thing. The fact that I could just click that one button and I had an application that was live on the internet for everybody to use it was a really important abstraction. For 95% of people who need to build an application really quickly, they want that. That is important. It's not that hosted services are bad, it's that there should be an escape hatch. All right, so I think I have approximately bored you to tears on the subject of all the escape hatches in Anvil. And really, I have not covered all of them. I'm very happy to talk about any of that stuff or more in the questions afterwards. But as I'd like to close out by talking about the design principles behind the abstractions that we built for Anvil and the abstraction that Anvil is over the web. Number one principle is code is good. You're telling a computer what to do. We have been telling computers what to do for approximately 3/4 of a century, give or take. And in all that time, nobody has come up with a better abstraction for telling a computer what to do than writing text in a programming language. People will occasionally try to create an abstraction, an alternative abstraction. They'll say, oh, you don't have to write code. Here's our whiz-bang app creation system. You just need to build a flowchart. It's really easy. Anyone can do it. And that's a false promise. That abstraction will fail and it will leak and it will sometimes do both at the same time. You'll either end up with things the system just can't do, it will fail, or it will leak and you'll end up with Cthulhu's own flowchart and you'll find yourself shaking your monitor, throwing it out a window going, let me write the code. So we get you to the code. Even in that UI designer, you remember when I wanted to format those dates, I wasn't dragging some kind of visual noodle from the database onto my form designer. No, I wrote a Python expression. And because I was writing a Python expression, I could use the datetime libraries. I could use all the power that was already good there. Code is good. Get me to the code. Principle number 2, and arguably the most important when we're thinking about this abstraction, is to be accessible. And accessible is a word that means a lot of things. And if I asked most people here what being accessible meant, they'd probably say something like, it needs to be simple enough for novices to pick up and use. And don't get me wrong, it does need to be simple enough for novices to pick up and use. It is frankly a stain on our profession that we have built the web, the greatest application delivery platform on earth, and then we said, oh yeah, you need to know 5 different programming languages and about 5 different frameworks to get anywhere at all. And yeah, I haven't even told you about the DevOps and the build tools. It's frankly shameful. Something as important as the web should be simple enough for novices to use. But just simple enough for novices isn't enough. To be properly accessible, you need to be powerful enough for seasoned professionals. Now, partially this is for the novice's benefit, because a novice needs room to grow their powers. If you stick them in a playpen, they will not grow, and they will eventually chafe, and they will look at the effort as wasted. But it's also for the benefit of the seasoned professionals, because, just because I can write those 5 different programming languages and 5 different frameworks doesn't mean I want to. And it doesn't mean my boss wants to wait for me to do it. And so it's important to use an abstraction that does not hide the power of driving a computer. And so using a real industrial programming language with a real industrial library ecosystem as much as anything else, and then providing all the escape hatches required for experts to do their expert thing, is the other half that is utterly necessary for making this thing accessible. And sure, you might look at these 2 points and roll your eyes, and I am here to tell you that this is not a pipe dream. And we, of all people, should know that. Everybody who is on this video conference is on this conference because of an interest in Python. And Python is the language that you will teach an 8-year-old as they first start playing with their Raspberry Pi. And Python is the language that powers Instagram. It's the language that DeepMind used to beat the human brain at Go for the first time ever. It is possible to be simple enough for novices and powerful enough for seasoned professionals. Python shows us that it can be done, and it is only the garbage fire of modern web development that ever makes us doubt it. Thank you very much.
That's awesome. Thank you so much, Meredydd.
All right, time for those questions, because I saw stuff scrolling through the chat logs. Here we go.
There's a couple in there, I think, yeah.
Right. Okay, so let's go with, from the top, are those modules available? Scikit-learn, Scikit-PG, you betcha. Yes, James posted the package list. And SQL Alchemy is there because sometimes you want it. I say it was a completely unfair pot shot at SQL Alchemy because there are people who need it. Can packages be added? Yes. And we will help you do that. Or if you need to do something private, you can always use the uplink. You can even use the uplink on the free plan. And yes, you can always host your own instance. Scrolling down a little bit in these questions. If you want to run PyCharm with all the completions, a remote interpreter for indexing. So PyCharm will give you some of the completions, but some of in fact, a lot of the stuff that is really useful about that autocompleter comes from the fact that it knows about the structure of your app. It knows about what's in the drag and drop designer. It knows about what's in the data tables. And PyCharm, and I mean, I say this with huge respect to the guys in Prague, because the IntelliJ tool family is amazing, but PyCharm lives within that stacked structure where it's not expecting to be able to know about your database well enough to be able to autocomplete it. It's not expecting to know about the UI that's, you know, several layers of abstraction away on the other end of a web connection well enough to autocomplete elements of that. So there are limits to how much that you can do in it. One day maybe we'll release a PyCharm plugin that tries to bring some of it back, but we can't bring all of it back, because the problem with developing it like it's a classic Python application is that you're constrained to this classic, you know, Python server-side web stuff, where it's not expecting to know about the rest of the world, and not knowing about the rest of the world is kind of part of the problem.
Is there any way to port over a SSH connection to that to get it? I know I've developed quite a bit in PyCharm on a whole different system, and then PyCharm can bring in all the libraries over SSH and use that interpreter.
Yeah,
or, you know, the libraries.
The answer is broadly no. You'd need to write a PyCharm plugin to do it. You know, not impossible. The data is in fact all there in the repository, and the format is documented, but
it's not quite in the normal form that it's expecting, kind of.
Yeah, because it's not. Yeah, it was not all Python code, right? It's, you know, it's compiled to JavaScript. There's stuff there that is baked into our RPC layer. If you are coming to the Python Web Conference, then I will be giving a talk that's a technical deep dive into Anvil that is showing how a lot of that stuff is implemented under the hood. And I think at the other end of that talk, you might get more of a sense for why some of the stuff would not just fall out of a code of a language server. Unit tests. What are the story for adding unit tests? Can I add unit tests in the same Git repo? I mean, yes, you absolutely can. There's even a way of launching the server side of your application in something like PyCharm via the uplink, and you can run unit tests with your graphical tools there. Client side stuff, there is basic support for the Python unit test library in the client. We are working on integrating that stuff with, you know, easier pointy clicky stuff. But in the meantime, absolutely, you can add tests in the same Git repo. You can add anything to the Git repo. It's a Git repo.
The reason I asked is the last time I tried, it was back in the Python 2 era of the Anvil, you know, web designer, and I think I added my own folder, own directory at the top level, and then when I saved on the UI designer, it blew that away, and so
yes, old version is definitely the key phrase there. Good news, basically.
Awesome. Anyone else have questions for Meredydd?
Do you guys have any forward-looking things for bringing in WebAssembly as part of this?
So WebAssembly, again, this is really a question to ask around, again, if you're coming to the, if you're going to the Python Web Conf, then I'll be talking about how the Python to JavaScript compiler works there. And that's really the point where something like WebAssembly would be applied. In practice, actually, most of what the client-side code's job is messing around with things that are abstraction layers around things like DOM nodes and WebSockets and things that are kind of part of the browser. And actually, WebAssembly works best if you have a big lump of code that communicates pretty infrequently with
a
the
big
main
computation module of some sort.
So I am one of the maintainers of the Sculpt project, which is the Python to JavaScript compiler we use, and we've talked about WebAssembly as a possible target. But it would be, it's not an obvious huge win for us, oddly, even though everybody is like WebAssembly all the things, and generally WebAssembly is awesome. Actually, it doesn't make a great compilation target for us for a bunch of reasons. It's not a great step for Anvil because it's
you would server-side process rather than client-side process.
Say again?
You would server-side process a heavy thing more than try and put it in the client.
Oh yeah. While that is true, the heavy stuff is all server side anyway. Yes, exactly. Sorry, I thought you were talking about things like ahead of time compilation, which you can do already in Sculpt.
Cool. Any last questions before we get to the door?
Yes. Oh, Michelle asks, can you describe the security features? Is it possible to secure a data dashboard to allow only specific clients to view? Calvin, may I have another 4 minutes?
Go for it.
All right, here we go. Okay, so let's go back. Let's revert to this version, pull up our Git repository, restore the version with the plot. Okay, so here we are with a plot. We're accessing some kind of data that we want to protect. So what we're going to do is we are going to add the Anvil users service, which is a one-shot user authentication system. And of course, you could build user authentication yourself, right? You'd make a data table, you'd have a column for email addresses, a column for hashed passwords. You need to make sure to do everything right, otherwise you'd let all the bad guys in. We've just done it for you. So all you need to do is run anvil.users.loginwithform, and that we will handle that. Obviously, you can fully customize it if you want to. There's tutorials on customizing it, but out of the box, it's the simple thing. Email and password, Google, Facebook, Office 365, Active Directory, client certificates, if you're really working with one of those paranoid organizations. I'm just going to leave everything on defaults for now. I'm going to allow new visitors to sign up as long as they've confirmed their email address. Yeah, all right, let's do that. Actually, go on, I'll do that. So, that, of course, this looks like a data table. It is, of course, just a data table. And in fact, the Anvil users.getUser function returns that row from the database table. So we can actually, we can do some manipulation with that. So first important thing is to log us in. So the first thing we do before we do anything else is anvil.users.loginwithform. And then over here on the server, where I'm arbitrating response to that dashboard. Yes, sorry, of course, I have lost my interpreter. So let's bring this interpreter up. Obviously, I write this as a script. Let's write this as a script. Okay, so we've got the uplink. It will start off with this pretty classic prelude, and then we will have an Anvil server callable function, which is get data, and it will check whether we are logged in. So let's go with, me is anvil.users.getUser. If me is none, and now I can just say, serving data for, and of course, me it's a live object, but I can access it like a database row. So I can access it like a dictionary even, and then I can return that data. And then, of course, this script will just run through and exit if I don't do anything about it. So I'm just going to do anvil server.wait forever. That's just like a while one sleep loop. Of course, you could write an uplink function that does just run through, right? It's a cron job that runs a one-off task and grubs through your data tables and does stuff. But here we want to hang it to hang around. Okay, dashboard data. Right, we are connected. Let's run this sucker. Of course, the first thing it's going to do is it's going to pop up a thing. It's going to make me sign up for a new account. I'm going to have to sign up for that's my email address. It's now sent me a confirmation email to meredydd@anvil.work. So I'm going to go off on another monitor and wait for that to arrive. Okay, there we go. Here is the email that's just arrived. Click the following link, confirmation. And now I can log in as Meredydd@anvil.works, and with my password, I can log in. Oh, and I've got an error. What's the error? Anvil has no attribute users. Ah, yes. So that error, if I go back to my application logs and find out where that error occurred. There we go. Module Anvil has no attribute users at dashboard data line 7. Let's go edit that code. Ah, yes, of course, I haven't imported Anvil users. Try again. While I'm at it, I can go to the data tables and notice that there is, of course, a new record in the users table for me with a bcrypt hashed password, and it's just managed all of that for me. I was about to say something that I'm not going to say on a presentation that's going to be recorded and streamed on YouTube. All right, see, and now it's authenticated me. You can see it's printed, serving data from Meredydd@anvil.works. It's worked out that I'm logged in that current session, and so it is allowing me access. So yes, you can build an authenticated dashboard.
That's really cool. You guys have done a lot of work on this.
For OAuth 2, would you have to handle that via uplink or handle your own server side or integrate on the client side? The answer to that is that you can build desktop 2. That you can, if you want to build your own OAuth flow, you would want to bounce the user through an Anvil server HTTP endpoint. And here you would do things like attaching things to the session, redirecting people out and redirecting people back, and then adding things to the session and doing an anvil.users.force login with a you can users. You could look up a row for a particular email address, and then force log them in via the user's service. Basically, you can implement all of this stuff yourself, and then you can free ride on exactly as much of the user's service as you want. Again, abstractions plus escape hatch. It's a theme. While I'm on HTTP endpoints, let's go. Let's make it return all the visitors. Let's just return all the names for all the visitors. Name for you in apptables.visitors.search. So now I can go hi IndyPy Anvil.app/API/ so I'm going to curl that /API/foo. And of course, I've just built a JSON HTTP endpoint. But I want that to be authenticated. And I could implement it myself with the anvil.server.request object. And I could pull out the all sorts of headers and things. Or I can say, well, actually, I've already got the user's service built in. I am going to authenticate against the user's service. And now, if I try this, I'm going to get an unauthorized. So I'm going to have to, I think that's the correct syntax for curl. Give it HTTP basic authentication with its secrets. Oh, no, wrong U. There we go. And now I'm authenticated against that endpoint. Again, you can do it manually, but there's a lot of good stuff in there.